Okay, so let's start, and please feel free to ask questions and focus in the class, right? When you are in the class, don't see WhatsApp, don't check emails, don't see WhatsApp, don't talk to anybody else. Just stop anything that you are doing and just focus. So this topic is again very important because we're learning about VLAN. You would have come across this term very often, and we'll see why VLANs are important. Okay, all right. Okay, so these are content. I have taken content from these places. So if you want to learn more about the topic, just open a book. Like this book is fantastic, top-down design by Cross and Ross. Possibly very good book to learn networking. Possibly the best book or one of the better ones. Okay, and many others are on the layer 2 security. All right, so we'll cover these topics. We look at the ARP protocol. Then we look at some of the text, then we'll get into VLAN, and we'll request you to do reading about VLAN and attacks on VLAN by yourself. So we don't have enough time left out, and we have to cover up to transport layer protocol. And then we have to also have 2 lectures on cryptocurrencies, cryptocurrency and blockchain. Okay, so now remember that we are still in local area network domain, right? Okay, and note that LANs are, when we say LAN, like your hostel, okay, how do you address each other, right? You know, by name, right? Maybe Arun, maybe Sawmill, maybe, you know, some name, or maybe Radha, or whatever, or John, etc., etc. You don't use the, you know, complete name, father's name, and all that. That makes your name, your identity as a global identity. You use local identity. As long as they are on there is only one Arun, for example, it works out. If there are two Arun, you may start calling second Arun as Arun P or Arun L or whatever. Okay, so whenever we send packets, whether within LAN or outside LAN, okay, address have to be unique. Now think yourself, these nodes that are inside, they know each other in some sense, okay, and they use only local addressing. Okay, and local addressing is nothing but Ethernet address. Now this Ethernet address, of course, are provided by a manufacturer, but they are unique. Okay, so now when you somebody is within the LAN or a machine is within LAN, it will use only local. It will use only local addressing, right? So LAN, of course, here would, you know, these are switches that we are showing, but in general, switches act as a this one, a wire, and where CSMACD can run. Now we have studied about switches and so on, right? Okay, so within a LAN, always routing is using layer 2 address. So layer, now Ethernet frame or packet will have source address and destination address, right, among other fields. So this is a header. Could be some other fields. We're not bothered right now. And rest is payload. Now payload will contain what? Most of the time it contains IP packet or ICMP packet. All right. Okay. Good. So we are here. Okay. Now question is, okay. So we are in this network. So and these LANs are connected to outside world, right? So I will. So let's assume that LAN, there's another LAN or something here, and then you may want to go to that LAN. Then there is always for a LAN a gateway router. I'm repeating these concepts for you. So any packet that's going out of LAN has got to go through router. Okay, then it enters another LAN and then travel. Then for that LAN also there will be a gateway router, and in this way the packet travels across multiple LANs to reach to destination. This LAN, in fact, could be just a single link. Could be. Okay, or it could be multiple nodes connected within a LAN where you use layer 2 addressing. Remember, in layer 2 you use Ethernet addressing or layer 2 addressing, and then for global routing you use IP address, right? Now whenever a packet reaches to other LAN, first thing it does is remove outer packet, outer header, and take out the IP address. Look at the IP address and then find out where to send it to, whether the destination is within the LAN, then it can be sent over corresponding layer 2 address, or it is not in the LAN, then it will send it to the gateway and gateway will decide where to send it to. Okay, so this is a normal method that we use. I hope you understand. Okay. All right, give me a minute. Any question up to this point? Are you able to understand? Yes or no? Yeah, I need answer.
Yes, sir.
Yes, sir.
Okay. So please keep in your mind, if the letter come, if you're communicating within your hostel, then you don't need any global address. You won't say, I am Pooja, I am daughter of Mr. Ramesh Kumar or whoever, and then who is resident, the permanent address this and so on. So that's IP address for you. You don't need IP address. And somebody, if Pooja is in hostel and someone say Ishi or somebody wants to communicate to her, will say just Pooja, name Pooja, right? Or may call some other name which is known inside. Okay, only somebody has got to communicate to outside world, then you need global address like IP address. Okay, so within a hostel, if one has to send message to each other, it can you just write a letter in case you want to do that, and then just pass it on to somebody who is going into that person's room, and then it will reach. Same thing happens in LAN. Remember this. Huh? All right. Now let's come to. So Alice is in the cafe. Let's assume the Alice is here. Just a minute. Okay. All right. So we are here. So Alice doesn't know. Alice has rebooted her machine, and then she got. In the last class, we studied about DSCP protocol. So DSCP, local DSCP server sends all these parameters to her. Says that your IP address is this one. Netmask says that this is your network's IP address. So that IP address is constant for every node. Like your hostel address is part of that global address. And then this local address, you say hostel, say for example, I don't remember your hostel name, Beas, for example, hostel Beas, and then it can say Puja. So Beas, hostel Beas, and the address of that is global, part of the global address of that IP address, right? So, and full addresses of Puja at Beas, at IIT Mandi, and all that, right? So, but Puja is local address. So now remaining part apart from Puja maybe is actually this subnet address. Okay, so let's not worry right now. And then you get DNS server's address and router's address, gateway router that we discussed about, right? Okay, now she wants to connect to DNS server. Okay, and DNS server address is 1.3.19. But that DNS server is within LAN. Okay, and this is global address, but she needs, or Alice needs, local address of this one, right? Assuming that global address has no relevance with local address, because the Ethernet address are created by manufacturers. IP address is given to you by router, basically ISP. From ISP you get that, right? All right. So now she needs to know what is the hardware. So like somebody has said that I want to talk to say some that for example, somebody comes to your hostel and says that I want to talk to this address 1.3.1.2.3.19, and they'll say who is that. Then then you'll say, what you'll do, everyone knows it's a global address, right? Everyone in the hostel knows a global address like 1.2. Then what is the mechanism? Security guard will shout out that who is 1.2.3.19. Okay, everyone is listening. There are two possibilities. One, because it's a LAN, right? Everyone is listening. So is that the one who has 1.2.3.19 will say, yeah, it's mine, and this is my local room number. Okay, and then security guard may go and then deliver whatever. Okay, that's one possibility. Other possibility is that this person's friend, for example Pooja's friend, will also shout out, okay, this is IP address of Pooja and her room number is this one. Okay, so this is how the global addresses are resolved. IP address is resolved into a local address. Then everyone knows Pooja, but they may not know 1.3.1.2.3.19. At least security guard doesn't know. Okay, so now what everyone can do is that everyone knows in the hostel, those who are listening, that Pooja is corresponding to 1.2.3.19, and they will update their table, and this updation of table is only for some time. Okay, because his IP address keep changing. All right. So this is a simple protocol. So this router, this machine where Alice says that where I want to connect to domain name server which is in the LAN. Okay, what is the Ethernet address of that? And this guy will respond, okay, my Ethernet address is this one, 1.3.156. Now what this machine will do, Alice's machine will do, she will create a packet, IP packet, and this will be IP address of this is sorry. So this is the IP address. I'm so sorry. I will repeat. I just yeah. So this is the IP address 1.2.3.48 is IP address of Alice. Okay, and then she wants to find out what is the local address of MAC address of this DNS server, which she has got from somewhere, right? Through DSCP. Now she shouts out that who has 1.2.3.156, and this guy responds that okay, my IP address is this one. Sorry, my Ethernet address is this one, and now you can use that. What she will do now, she will create a packet okay, and then this is the IP address, and then she will encapsulate this in a Ethernet packet where she will write this address, Ethernet address here. Okay, this is how it works. Okay, and then every host that's listening changes his own table that Pooja corresponds to this room. Okay, so it's like this IP address is corresponding to the MAC address, and how long this relationship be alive. Okay, maybe that Pooja has come to hostel only for a week. or something like that. Okay. So now when I am in a LAN and I have to send a packet to anybody, okay, and I will know about IP address of that person, say destination. I will look at my table and see what is corresponding to this IP address, Ethernet address. I will create my IP packet with IP address, IP destination address, and put this inside Ethernet frame, Ethernet packet. And Ethernet packet, I will put or Alice will put her own source address and destination address of the machine in the LAN where she wants to send it to. Okay, all right. So this is how it works. Okay, where is the problem here? Anyone? Think, na? Where we said in the last class, we discussed this point that whenever there is a broadcast, there is an issue. Where is the loophole in the protocol? Note that the whole networking world is based on trust. Okay, we have seen 7 layers, 5 layers in it. IP protocol. Each layer trusts corresponding peer layer, and each layer trusts a layer above that. If that trust is broken, nothing much can be done, because at each level there is a state machine that's running. Okay. Now, if the trust is broken, then you cannot. Then the whole system will malfunction. Okay, just anybody can think where can be the problem in this protocol. You are broadcasting within a LAN. I need layer 2 address corresponding to that IP address, and many people have this understanding and they respond. Where can be the problem? Similar to what we have seen in earlier case, last class.
Some adversary can claim that it is it has the following IP address and send its MAC address.
Fantastic, fantastic, very good. This is exactly anybody, it's based on trust. Okay, if somebody shouts out that I am Pooja and this is my room number, then the security guard in front in your hostel will accept that. And what will happen? Any packet that's coming with that IP address, he will send it to that room. Okay. Now the problems are here that like in case of IP or similarly for Ethernet, there's nothing authenticated. Source is not authenticated. Okay, it's based on trust. If source is not authenticated, then anybody can pose as anybody else. Okay, all right. So now this is attack number 1. So Alice wants to know Bob's MAC address. And of course, Alice will know Bob's IP address, right? So now IP address but in order to communicate with Bob, she needs Bob's Ethernet address because they are in the same hostel. Okay, or same subnet. Okay, or same LAN. So, okay, so now Alice sends this request with Bob's address, and then Trudy acts faster and sends replies back with IP address of Bob. Says that IP address of Bob is this, and hardware address, Ethernet address is something, right? And that is non-existent address. Like, somebody responds like Pooja room number is 120 and hostel has just 50 rooms. And then security guard may not know all this, may not be very intelligent, will send this to unknown, put in an envelope and then send it to room number 102 and it's all lost. Same thing will happen is now it's called denial of service address because address is non-existent. Okay. All right. So now as we discussed in case of LAN, every LAN will have a default router or is a gateway router. Okay. And then for outside world, packet communication happens to that, and then DHCP will give this IP address of this default router, right, in the beginning. So when we boot up our machine, we'll get default router's address. Okay. All right. Now, but this is IP address that she gets. Alice gets IP address of this through DHCP. Now she wants to, now note that this is also part of, default router is part of Ethernet. It's at the edge of the Ethernet, right? From there it's connected to internet. So is Ethernet address is required or hardware address is required? Then Alice machine will do ARP. Okay, who has, okay, I want to know hardware address of corresponding IP address of this router. And then Trudy smartly says that this is the IP address of router. He will write in reply the IP for IP address of this router. The Ethernet address is his own address. This has some Ethernet address, right, which we call HDA, hardware address of Trudy. All right. So this machine will know that now, okay, I'm sending packet to router R and hardware address is HDA Trudy. And then all the communication will happen, which was supposed to go this way, but what will happen? It will come to Trudy because Trudy will receive this. And there's a much bigger harm, right? All other packets, when listening to the response back by Trudy, they will also update their table. They might update their table. Actually, they will update their table, and then they will also understand that router's address is Trudy's hardware address. This router's IP address corresponds to Trudy's hardware address. Okay, any question? Okay, so based on this, can we do, can 2D do MITM attack, man in the middle attack? Very simple, right? Now, man in the middle attack, Alice is sending, we have studied this, right, in case of encryption, symmetric encryption. Alice is sending a message to Bob. Okay, and in between Trudy is there. She will receive the packet and then make modification and send it to Bob. Okay, and Bob will always think that he is receiving packet from Alice and so on. Okay, all right. So it means that in between Trudy is modifying the packets and sending it to Bob, and Bob will never come to know. So we can do very easily this attack, right? So Alice does ARP for router R. Okay, and Trudy responds back with, I'm sorry, in this case we'll assume that Alice wants to communicate with Bob. Okay, and Alice knows Bob's IP address only. Okay, and then the Bob is, Trudy responds back with Bob's IP address and its own hardware address, right? Is the last step. Okay, now what will happen? The message will come. Alice will frame the message IP packet, put this inside Ethernet frame, and then put IP address of Bob. Okay, and of course, she will create IP address, IP packet, and put this inside Ethernet frame, and here she will put Ethernet address of recipient, which should ideally be Bob, but now she puts his Ethernet address of 2D. So here Ethernet address, destination address is Ethernet address of 2D. Now 2D receives this, and 2D knows what is the, and he does all the manipulations. Okay, creates another IP packet with all modifications and puts this inside Ethernet frame, and here he writes the destination address of Bob. So Bob will think that it's coming from Alice, but what he will receive is all this modified contents. Got it? Any problem? Any issue? No? Okay, all right. So how do we take care of this issue? Okay, if this mapping that is there in a computer, okay, IP address to MAC address, because we have seen that each machine contains this table, each machine contains this table, and then this IP address, it will have various IP addresses of machines in the LAN and corresponding Ethernet address or MAC address. Okay, so if this address is right in the beginning static and remains static, which means remains the same, then the problem is solved, right? We don't need actually ARP in some sense, right? But this is not a great solution. In normal case, right? I mean, like in a LAN, people keep changing. I mean, people come from some other place, connect to a LAN, and then go away. Now, this method of address stable static address can work in an environment, for example, lab, when everything remains static and nobody from outside is allowed to enter the lab. An extremely secure environment. Okay, for example, you are given IP addresses which are permanent addresses. In many places, there are permanent IP addresses are there to the machines which never move. Okay, and then these kind of things can be used. Okay, all right. Otherwise, this method is not really. Now, second thing is that ignore unsolicited mapping in response. Okay, so now 2D response back to Alice's request. Then if it comes from 2D, then can switch find out that 2D is responding. Now, switch may have intelligence, right? Apart from these protocols, if switch can find out the response is coming from 2D, not from Bob, then it can reject that. Okay, so basically switch can do ARP inspection and monitor the ARP poisoning packets, and then take care of that, disable that port or do something around it, right? And then of course port security mechanism, which we have studied earlier in the last class, they limit the number of people that can be connected to a port. Now, normally we assume that one machine is connected to port, but that may not be true. In a port, you can draw Ethernet port. I mean, this is a switch. It has multiple ports. On that port, you can take connection out, and into that you can connect a small LAN. Nobody stops you from that, right? So just say that if you allow just one MAC address per port, then you can limit this damage of this kind, right? All right, and then of course this is not very practical solution, that separate networks by routers, not switch. Okay, so create a small subnets. All right, so that's all about ARP attacks, right? And countermeasures. Now let's come to a concept called VLAN, because you would have come across this term very often. Okay, very often, right? You should know what VLAN is and why we are discussing this. Not because you need to know about this technology, but also because it provides security. This is your campus network in general. Okay, note that this symbol is switch. When we say switch, it works at layer 2 or Ethernet level, right? Like your hostel room. It's all local, right? Okay, and whenever we say router, then it works at layer 3. So all the communication that happens in layer, in subnet, Now this is a subnet. It means that now for all these subnets, part of IP address will be common. This is called subnet address. And then for each machine here, these addresses can change in some bit position. Okay. All right. Now with this understanding, let's start discussion. Now it means now we are connecting all the departments, comp science department, EE department, mechanical department by Ethernet only. Okay, so you can see that each department has a switch or multiple switches, and they are connected to bigger switch. All right. Fantastic. And you connect a web server, mail server, and of course there will always be a gateway router. Now tell me, what is the problem here? Anyone? So you have many departments and hostels, and you can add to these hostels also. If everyone is connected with Ethernet, it means that your LAN actually expands to whole institute, and there is one router. Where is the issue here? Everyone addresses here are all unique, so everyone can send to everybody else. Think, what is the issue? Anybody? Okay, by this logic, why not connect whole India over layer 2 switch? Addresses are unique. Of course, these are flat addressing, it works. But you know, the learning table concept, you know, self-learning, everyone has to learn where other machines are. Okay, which port other machines are connected to, right? And then this table size grows. If this table size grows into million and billion, then of course it will take a lot of time. That's the first problem. What is the second problem? Bigger problem. Are you listening? I'm concentrating. Then you should be able to answer this. Anyone attempt at least, right?
Single point of failure.
Yes, single point. Very good. This single point of failure. What else? Assuming that it's very reliable, what could be other problem? The other problem is, of course, everyone is listening to traffic. You know, all this, your campus will have at least 3,000 students, I don't know. Maybe 3,000 students listening to everything that's happening. And there can be some malicious people also in the campus, right? And they can take advantage of that. If you're not encrypting the data, etc., at Ethernet level, all is visible to everybody else. That's first problem. What else? And you know, while the learning happens and while we are using DSCP, ARP and all that, they are all do broadcasts. Okay, when they do broadcast, then you know, if the every node will do then to learn. Okay, as soon as a new node comes in, it will start doing ARP and so on and so forth, right? And this guy doesn't know where where the destination node is, and again there will be a lot of broadcast. Now all these broadcasts will take away bandwidth, is waste. Okay, so we need to reduce this waste. So that's the reason we need to make smaller subnets and connect those subnets through a router, like hostel. your hostel will have a router, because they want the broadcast to go only to maybe in the hostel. Okay, they can afford that kind of broadcast or that kind of security. Similarly, in a department LAN, okay, broadcast domain will be only department. Okay, so now what we can do is that we can create this kind of LANs in some sense, okay, and connect these LANs to a router, because only routers work at layer 3. So now if somebody from this IP address, a com science department, wants to communicate to EE, they can't do it locally, like within from your hostel to another hostel. You can't just shout out and then do things, right? You may not know anybody out there, but still you want to communicate, then you have to know the IP address of that, and knowing Ethernet address will not help, because there's no way Ethernet packet can go to this place, because it has got to go through IP packet. It has to go through IP router, and router will send it here, and so on. So there's one solution. Now what's the issue here? Okay, but what you want is that anybody who is CS student, computer science student, all want to receive the same broadcast. Then how this problem can be solved? Now let's assume that everyone is in a building, one building. Then problem is solved. Now let's assume the CS department goes to EE building and wants to connect to port here. Then what is the issue? Now how can this student who has moved from com science to EE can be part of this subnet where it receives all the broadcasts? Can it be? No, because now everything is happening through a router. Okay. All right. So this is one problem. The managing the movement of people is one problem. Second is that inefficient uses of switches. Switches are generally big. If you look at your switch in your department, it will be at least having 1K ports. Of course, in homes you have 8 ports, right? I mean, look at your Ethernet switch, which is part of router. You will say generally 8 ports. The ports are nothing but where you can plug in your cable, right? Ethernet cable. All right. So now in home, how many of these you use? Just one, maybe out of 8. Okay. Similarly, in department, your 1024 or 2048 port switch, you may not use all of them. So it goes waste. Okay. All right. So now what we can do? And when people move across buildings, then you do rewiring for one student who is working from different department but wants to part of your LAN? No, you cannot do that, right? Is a problem. So now we have smart and big switches. Okay, these are very expensive, and it has a lot of features. Unlike your small box you buy, which you can get it 500 rupees. Big switches are usually in the order of 5 lakhs, 10 lakhs kind of rupees, right? So, and you can create different trust domains. This is important keyword, right? Like guest wireless, employee wireless, whatever, department wise, or something where file servers and others highly secure systems are, and so on. And you can do this without actually buying separate switches. You buy a big switch, and then within that switch you create multiple LANs where communication happens only within that LAN. And if you have to do something else, then you have to go through a router. Okay, so it's like this. Now we come to the concept of VLAN. VLAN says that we can split switches across multiple LANs. Okay, say these ports, right, like this, assuming that there are 6 ports in these 3 first, or any 3 belong to orange LAN, and then the next 3 belong to green LAN. Okay, so this is basically port based. You can say that if anything comes from say node A, it will go only to B and C. Only B and C can see this broadcast traffic. So this traffic, although A is sending to, is doing some broadcast, it will not go to these nodes. And similarly for green to orange. Okay, and now if you may say that if C wants to communicate with D, then there's no, although they are part of same switch, it cannot go over Ethernet. Then it has got to know the IP address of this node D and create a IP packet, put this in Ethernet frame, and that frame will go to router, and router will then send it to, take out the Ethernet packet, create another Ethernet packet, inside will be that IP packet, and that IP packet or that traffic will go to wireless LAN Y. Okay, so you across LANs we need router. Okay, all right. So now if we have, now this is about one single switch, right? Now question is that suppose we have two such switches. Okay, can we say that some nodes here corresponding to orange LAN or VLAN X? Okay, some switch like some ports 1, 2, 3, 4, 5, 6. These are the ports, right? Can we say these 1, 4, and 6 belong to orange port, the remaining belongs to green port? So anything that orange one is sending will also go here. Is it possible? Yes, that's possible. Now we can connect multiple switches. Okay, so like this is CS department switch, that's in CS department, this switch in EE department, and then we can say that some ports belong to CS, some ports belong to EE. Any question? But now, even now, anything that is from orange will go to nodes in orange. Anything that goes from green will go to only green nodes in different department, right? EE department. And if orange here wants to send it to green, then it has got to go through a router. Okay, so now we can, at layer 2, we can connect two switches. And now we are talking about only layer 2 communication. So we can say that a port here, let's assume 1, 2, 3, 4, 5, 6, 7. In this switch A, port 4, 5, 6, 7 belong to red LAN, and remaining belongs to orange LAN. Okay, similarly here in LAN B, similarly we can say this port, say 1, 3, 4 belong to red port, red LAN. So now if any red LAN sends packet, then it will go to all these broadcast packet, all these nodes. Okay, all right. So now we can create these LANs in this way, right? We can connect any number of switches, and we can have these machines belonging to LAN A, B, or C, or whatever, right? Okay, all right. Now please, we can also have this, suppose there are multiple switches in different floors of the building, ground floor, first floor, second floor, and so on. Okay, then there are some students which belong to CS department, some may belong to E, some may belong to DS, and accordingly we can, although these switches are, these LANs are actually physical LANs are different, but we can create VLAN department wise. All those students may sit in any floor. Okay, all right. So now there are many ways of creating VLANs, which could be MAC address based or Ethernet address based, or it could be port based. What we have discussed so far is the port based, and also it could be protocol based, which these two will not study. We'll study this concept in very brief. So now we have port based VLAN. Okay, now in the switch we say that switch port 1 to 8 belong to E department, and port say 9 to whatever belong to 9 to 15 belong to CS department. Okay, all right. So on any machine that is, and switch is intelligent switch. So any traffic that comes from any machine on the port, any of these red ports will traffic will go only to broadcast traffic will go only to these ports. Similarly here. All right. So now we can buy a more expensive switch, and then we create multiple LANs within that. Okay, which we call as port-based VLANs. All right, and switch management software is there, right, to take care of this. So effectively it works like this: there is a red LAN and there is a separate blue LAN. Okay, all right. Anything? Now question is that fine, you have created this. Okay, and any traffic that goes from red to blue has got to go through, or E to CS has got to go through router, because these are independent lines. I mean, these are actually two independent lines, so it has to go through a router. All right. So in practice, you will find most of the switches have both layer 2 switch and router. Right. So we can create this kind of mapping here. Okay, which will say that port 1, 2, 3, 4 belong to VLAN. Sorry, port 1 belong to 1, VLAN 1, port 2 belong to VLAN 1, and port 3 belong to VLAN 2, and so on and so forth, right? Okay, now the question is that now we are connecting two switches of this kind. Okay, one is in say one building, this is in second building, and there are students of EE and CS. Okay, so now in building 1 we can say that port 1 to 8 belong to EE, ports 9 to 15 belongs to CS, and second building ports 2, 3, 5 belong to EE, and port 4, 6, 7, 8 belong to CS LAN. Fine, we can do that. But now the question is that how does the packet from this any one of these will go to all these red ones in case of broadcast, or even in case of unicast? Because unique, say if you are part of the same hostel, you can shout out the local name. Okay, so now you are part of the same hostel, which is not by physical boundary but by something like, I mean, it's like you create a group, a tracking group, right? And tracking group spans multiple building, but these are all local, everyone knows everybody else, right? So anything that you send to any member of that has got to go over this VLAN. Okay, now we say now these red packets have got to go to this side, and this switch has got to send it to all these ones, will be through a special port which we call is trunk port. So each switch will have a trunk port and through which traffic can go. Now the question is that how does this switch know that it's receiving red packet or blue packet? Because red packets correspond to this LAN and this. But how do you know in Ethernet frame, if you have only, if you look at header, it has only source address, hardware address or Ethernet address, and destination. So how does it know whether it's coming from these ports or these ports, other ports? How does it know? Anybody? So like students going from one building to another building correspond to different clubs. We'll say that one who is in the hiking club will use track pant, and one who's in music club will use Indian traditional dhoti kurta. Okay, then okay, and then here when they reach to other building, the security guard knows that there are two meetings happening, and then The people who are coming in track band will be sent to hiking, the room where hiking related meeting is happening. Other will go to somewhere the music is happening. Okay, so we need to tag these frames. When they go through this trunk ports or link, we say that whether you belong to this LAN or other LAN, correspondingly we have LAN, we'll color them. We will say that you will have some ID, LAN ID. Okay, now where this LAN ID will come? Because Ethernet frame does not have a field corresponding to LAN ID. So now we say that we are modifying Ethernet frame, and if and then we'll inserting a field here. This is a normal Ethernet frame, and we'll putting a extra field we are putting here, which will define a tag. It's called VLAN tag. Like we'll say that your track band or red color or blue color to identify them at other place. So in that tag there are some fields, and one of the important fields will define the color, whether or some identifier, which will be VLAN ID. VLAN ID. Okay. So now using VLAN ID, whenever this machine, this trunk port sends a packet out, okay, to other machine, it will tag the packet as like here is red or green using VLAN tag. And any packet that is received for local nodes are just switch will send it to appropriate one and will not tag it. For internal consumption, you don't need tag in that physical switch, and for something that's going out to that VLAN in different place, then it has got to be tagged. All right, so this is the concept. All right, please look at it when you get time. Okay, and now this gives the algorithm, right? And now broadcast packet is received from a machine, a laptop, say Alice's laptop, and it is for, okay, that is for local consumption, so it will not be tagged, and it will be used, it will be sent to appropriate port where the other machine is. Now if this is for this is for corresponding to person who is in different building or different switch, then it will be tagged. Okay, all right. Now how this will be done, what is the mechanism, you can learn more if you want. All right, okay. So advantage of VLAN is improved security, because your broadcast domain is, first thing, is reduced, and now only subset of, because of that only few people can see your broadcast. Okay, it has reduced cost because you can create multiple switches out of that, better performance because of the simple reason that you are not sending it to everybody, and more efficient to manage a single switch rather than multiple switch, and more intelligent features you get. And of course there are many attacks, okay, like VLAN hopping attack, and then double tagging attack, and so on and so forth. So we'll not discuss this. If you are interested, I will send you material. Earlier when I taught this course, we discussed some of these, but we don't have time now, for remaining, what your part of the course. Just we have 6-7 lectures left out, so can't cover that, right? So what we have done at year 2 now, we have studied DSCP attack, ARP spoofing attack, and then we have studied about concept of VLAN. Okay, any question? Internal working of this, if you want, you can please read it from almost everywhere. Every book will contain this. If you type VLAN into VLAN architecture, functioning, etc., then you will get all the data. Okay. All right. Any question? समझ में आ रहा है नहीं आ रहा?
Yes, sir.
Okay. All right. See you then on Wednesday. Bye.
Sir, we want to ask about the ANSEM.
About what?
ANSEM, sir, ANSEM.